Hello, 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 hello. Yes, so I am audible on the stream. That is good to know. Okay, that is good to know. Let me do one thing. Okay, I'm just trying to set up all the things. Yeah, so welcome back. Whoever is new to the stream, make sure you subscribe to the YouTube channel. Okay, if you wanted content around DSA, around data structure, around hackathons, or any tech related topics that should be related to C++, and Python. These are the two core languages that I am initially thinking of focusing on. Okay? Other than that, I might not focus it as of now, but let's see what will happen. But yeah, right now I'm trying to learn system design. That is what we are going to do today. So yeah, let's not waste any time because I really am excited to learn these things. Okay? So when you scroll through Instagram, stream your favorite show on Netflix or shop on Amazon, you probably don't pause to think about what happening behind the scene. Yeah, we did not think about much, yeah, or at least the non-technical guy. And even for technical guy, most of us really don't care about whether how is this thing working or not. Okay? Other than some of the guy who has a senior position in the industry, or maybe someone who is into the Netflix, a similar company. But with every task and click and refresh, complex network of interconnection component works seamlessly to deliver a smoothless experience. Okay, that is true. Behind this seamless experience lies the art and the science of system design. Okay, so yeah, these are all the things that, yeah, if you are able to, if hundreds or thousands of people are able to see a particular thing, it was due to the system design, I would say. But yeah, it is one of the things that is important to scale up the website that you wanted to. That you are watching. Let's suppose even for this particular website, this my has definitely they have used a proper system design thing to scale this up for depending on how much traffic they are getting. Okay, so that we will be learning as we go forward. Okay. So what is system design? As its core, system design is the process of defining how different part of software interact and meet functional and non-functional requirement. Okay, so yeah, so if you are not aware of functional and non-functional requirement, functional requirements are those requirements, but like those are what we are going to do, yeah, in the particular app. Let's suppose if we are clicking on this, what is going to happen? These are all functional requirements. If I am seeing all this, what will be what are all these things, how they are going to look like, what is going to happen for what. If you click on this button, if you click on this button, these are all the things that are comes under functional requirement. Okay? And then what does non-functional mean? Okay, so non-functional is how well it should do, but I think this is not the true definition. I think I guess if I do ChatGPT explain non-functional in depth more. Non-functional requirement define the system behavior. Just define the system behavior, how much load, fail, what will happen when there was a failure, time and scale. All these are comes under the non-functional requirement, which are not the initial things that should be comes under functional requirement. You could say it as a non-functional requirement. Okay? So these are all the things that you should be, these are all the terminologies at least you should be aware of. Okay? It's not about writing code, at least not yet. It's about making the high level architecture decision that balance and scale. Yeah, so the thing is, when you're trying to scale something, let's suppose if you build a website. Okay? It could be either any website, or it could be either Netflix website, it could be either a Amazon website, it could be an Instagram app, ठीक है. तो if you wanted to scale that thing, ठीक है, तो it will totally depends on what are the requirements, how much traffic you are going to get. So depending upon all these trade or all these initial inputs, or ठीक है, तो all of these you have to make certain trade-off. Let's suppose if you having much more traffic on Sunday, so you have to scale the servers. Yes, if you are not aware of what I'm trying to explain to you, you will be learning about it going forward. But if you are aware of this concept, yeah, so definitely you have to be aware. You have to make some trade-offs. If you, let's suppose for the cost, on the basis of cost and all of these, okay, so we will be learning about all of these. And there was this one website, okay, I will. Okay, what was the name of this website? Okay, I just forgot about that. Let me just do one thing. Okay, this is the website. Okay, let me just do one thing. Yeah, so this is the website. If you are not aware about it, we will also be exploring this website again. So in this you have to like you will be able to see what is happening when you are installing a firewall or API gateway, message queue, loaders, or all of these. Okay? So this is a beautiful resource you should follow, and this is a gamify experience. Okay? This give you a gamify experience where you can just drag and drop. Let's suppose if I wanted to do this, I can just place it over here. Okay. Yeah, so and then I can link this to this. Okay, so this is how it goes. Okay, let's suppose and then it is telling me that this is initial tutorial, and then you can create your own part also, where you will be able to understand what is happening over all of these. Okay, I think this. Okay, so this does connect. Okay, they wanted me to do some of the things. I think this will connect to this. Yeah. So this is how you are going to get all the thing. Here you can look the budget. Okay, let's suppose what they wanted me. Okay, the CDN should be connected with the file. Is this the file storage, right? No. The CDN should be connected with the file storage. Okay. And then they want us to have a SQL DB that will handle the search traffic. Okay, so we have to install this. Let's install it in between, and the file storage should be connected to the compute, but isn't it already be connect the compute to the is this the compute, right, to the file storage? But okay, use the link tool. But isn't it already been connected? So this is firewall, this is load balancer. Okay, the I should be also installing a file storage again. Where was the file storage? I think that is what I need to do. Where was the file storage? Compute, right? This is the same. Okay, I think this is the file storage. Okay, compute to SQL DB. Okay, I just need to connect this, and let's play. Okay, so this is how it is happening over in the real time, and here you can see the cost of running all of this, and based on the cost, if it is if we have installed everything correctly, it is going to go get us some score. And this is how you can experiment whether your you have created a good enough system, ठीक है. So we will be exploring this also as a resource, ठीक है. तो this is for the future reference. I will not be confusing you guys, ठीक है. So yeah, let's just move on. As it's at its core, system is the process of defining how different part of a software system interact to meet both functional and non. Okay, so we have read this thing. It is not about writing code, at least not yet. It's about making. Okay, so we have read about it, all the cost or the performance. We have to make certain trade-off what depending on what our use case was, to balance the scalability, reliability, performance, or maybe cost. Okay, so we have to take some of the decisions. These are all the things that we have to do in this system design. ठीक है. तो रियल लाइफ एनालॉजी. तो लेट मी डू वन थिंग, लेट मी कॉपी पेस्ट दिस. वी विल ऑल्सो बी मेकिंग नोट्स रिगार्डिंग दिस, ठीक है, so that we can refer it later, ठीक है. तो वी आर डूइंग all of this. If you have already joined my channel before, you should be aware of this thing. So we make these notes on a daily basis, ठीक है. तो so that like we can revise these after we complete or I try to revise it on certain interval, because I think after some interval our brain automatically forgot about these topics. So it is necessary to remember it on a timely basis, ठीक है. तो it will be like for me I think of revising all of these in Sundays, ठीक है. तो Sunday stream was all about revising all of these things that we have learned already. So yeah, let's just move on. A real world analogy, ठीक है. तो a real world analogy was to designing a skyscraper. Okay, the word, if you are not aware about what a scraper is, let's suppose if you are seeing this website, you are trying to get all the data what is all written in this page or any page. Let's suppose if you are wanted to scrape from GitHub or maybe some other e-commerce website. Let's suppose Amazon.com. So you can scrape all of these. You can fetch all of these. That is what you can think of as scraping. Because skyscraping, I think this should be similar. Let me just search it just to be confirmed कि whether I'm right or not. Meaning an extremely tall building. Okay, I think I was wrong. A skyscraper is a building noteworthy for its greater height. Okay, so something that is extremely tall. Design something that is extremely tall. Imagine you are designing a skyscraper, ठीक है. You do not start by laying bricks. Okay, yeah. So where was that? You don't start by laying bricks. You start by asking question, how many floors will it have? Yeah, so that is true. See, I have already told you about this thing. So if you are, let's suppose if you are there was these thing also, right? I think we should mark it as done. So this we can see it over here, though I don't want to see it again. There are some topics that needed me to purchase them, so I will not be purchasing them, I think. Let's see what we will be doing. Okay. Let's move on where we were. Okay, so we have something, let's suppose, a real world analogy. Yeah, so let's suppose if you get any problem, it does not matter which problem I am referring to. Any problem, what you will do. Let's suppose if you are getting a hackathon problem. When you get the problem at first, what will you do? Do you start coding? No, right? What you do, you just break down the problem. You try to think what is happening in the problem, what they want from us, what are the functional requirements, what are the non-functional requirements that is needed. These are all the things that you think on your mind. Then that is how you was able to build something. If you really wanted to build it from the very scratch. Because even nowadays there was AI, so AI will on the back of the thing it does almost the same thing. Okay, so it does a simple system architecture spec it create on its own. Okay, so and then it try to execute the spec. Based on the spec it try to design all the things and create the files that needed to be created. Okay, so that is how we do. Okay, uh, once the requirement are clear you created a blueprint showing how everything fits together, the foundation, the structural support, the plumbing, the electrical layout and the elevator shaft. Okay. You also consider how different system interact and such as how plumber might affect the yeah, so that is true. Let's suppose if I try to click on this website, how is the clicking on this thing going to affect this website. Okay, so let's suppose if I click this, so it is going to like redirect me to in a different route. Okay, so if you this if you can look at, okay, if you can see it, I was redirected to a different route. So these are all the things that we should be thinking of, that yeah, what will happen if we click on this thing, what will happen with if we click on this. So, and then there was one more thing, we have to make all things as user friendly as we can. Okay? So, yeah. You also consider how different structure interacts, such as how plumbing might affect. Okay, so yeah, we have already did. So these are all the things that we need to be aware of before we build anything. Okay? We have to think of all of these. Okay? In the software world, the translates to architecture, the overall structure of the system. Should the system be built as a monolithic set of microservices events? I think this is a paid wala part. I think I might skip the because going forward when I try to see some of the things it is uh, paid. I think I was thinking of why not switch it before. I have this resource also, which I don't think so is paid. At least that is what I wanted to believe. Okay. It want me to log in. Let me do one thing. Okay. I will log in first thing. I think it is free. We can definitely check this out. Okay. Should we be going with that part? I don't know. This is written by Aslam Amit. Let's see who is this guy. Let me who's this guy? What it does. He works on the Microsoft also. He's a great guy. He posting. It is free, yeah, but I don't know. Do they also have charges something? The charge for the courses, right? Not for the blog. Okay, that is understandable, but they don't charge for the blog, right? And I have one other thing. We can go with GFC system design. We can follow this resource also. I think this is also nice, good enough resource to follow. I don't say the best, but yeah, it's still good enough. But I think we should be going with this. I don't know. But I think going forward, when we try to understand certain topics, it will be paid, and I don't want to pay anything. It has why the upgrade make your website faster, the protocols, UDP, cookies, okay, so data set cover many things. Okay, so let's see. I have already read about one thing which was these here. Let's see how detailed it is. Secrets and rules to be given. What binding protocol I think they have covered most of the things, but do they have covered everything? I don't think so. It is hard to find a good resource. I have some other resources also. This is also a good resource, but it was not updated from. And I don't know. We do not cover WebSockets. Maybe we cover polling. No polling. Is this thing paid? Okay. Just a moment. So where was I? Okay, so I'm just confused on which is the best resources. We can do one thing together. We can either be initially going forward with this resource here, and we wherever we find here, wherever what I think starting from here only we will be yeah, we have to switch to some other resource here. We will be seeing which resource we will follow after this, but yeah, let's just go forward with this initially. Well, I don't think so. I will be paying 2000 monthly to read this resource. Yeah, we might also explore some of the medium articles here, because I think that is also one of the good resources that we should be following throughout our journey. Yeah, so let's do let's start from where we left. Okay. In the software world, this translates to architecture, the overall system of structure of system. Should the system be on a monolithic or a set of microservices or an event-driven system? ठीक है, तो if you are not aware about what is monolithic or microservices, monolithic is when we create all the functionality in a single file. ठीक है, तो that all the code lies in a single file or a single everything whichever we have done, we do not break it down, we write it in a single function. That is something monolithic is. And the microservices is where we distributed our everything and decouple all the things, so that like it, even if a certain part of our code does break, ठीक है, तो it is not going to hinder other functions, or it is not going to break the code and stop the website. ठीक है, तो that is where the microservices come in. ठीक है. Okay, so the core modules are database, services, load balancer, cache, message, and API. We will be learning about what are these going forward. I think here this is caching, this is DB databases, and yeah, we will be learning about these interfaces, how these components communicate with each other. So this is how they communicate with each other. They use REST API, gRPC, and these are all the things. Together, then data, how data are stored. So yeah, this is where the data structure and algorithm comes in. Together, if you are aware about, okay, so hello Nandini. Okay, so data. ठीक है, तो how data is stored and managed, access and keep consistent. ठीक है, तो this is where the data structure comes in. ठीक है, तो how does we store the data? That is one of the things. Let's suppose even for you can take an example of your own room. ठीक है, तो if you have stored your books in a certain way, ठीक है, so that after, let's suppose if you are trying to search for a certain book in your book cell, ठीक है, तो if you have a big, we are considering, ठीक है, you have a book cell, ठीक है, तो if you have placed it in a proper order, you will be going to your cell and you can pick any book that you wanted at that time. ठीक है, तो if you have make it in a structured way, only then you are able to like get the book that you wanted. And let's suppose if you have not, you have randomly placed all of the book and the book is placing somewhere else, you will not be able to tell which book you wanted, and you have to search all the books so that you can get your book. And at worst case scenario, you might also have to check every last of the books. That is how important is that storing the data is, and how you manage it so that you can access it. And yeah, so second is, okay, 10 big questions of system design. So we have one other book also. I forgot about the name of that book. Okay. these things. I don't know. It does cover some of the things. I don't think so. We are going to get more depth in this. So we might also refer this thing also. Because I'm a little confused whether I should be going with this or that. You definitely have heard of this book. Okay. You must have heard of this book. So I was thinking of going forward with this book, but I don't know. Should I learn everything from here? I think we should be starting from here because we are still the first. This is a good. These are all the good resources. I don't argue, okay? But right now I think we needed this thing more than that. We have to learn these things. Okay. Yeah, we can start with this, and then we can go with the other wala part here. Okay. Okay. So we can start from here. Okay, so I will be skipping some of the things in it. Okay, so the initial part where I don't wanted to read these things. Okay, I think till here I will be starting it from here. 38. So let's just jump on to 38. This is okay. Okay. Yeah. This is such an important concept that we are dedicated an entire chapter to it. ठीक है, तो this is definitely a important chapter. ठीक है. But big O time is the language and matrix we use to describe the efficiency of algorithm. That is true. Not understanding it thoroughly can really hurt you in developing an algorithm. Okay. So these are all the things that you should be known about. ठीक है, to really come up with the difference, or to come up with which to choose. Let's suppose if you wanted to choose a merge sort between merge sort and bubble sort, what are the trade-off, how well it is going to perform on the worst case scenario, the best case scenario, and all of these things. So at worst case scenario, all the sorting algorithm, I think it will be taking almost n log n. Okay, so but you should be aware of these topics. ठीक है, तो so that you can able to judge or justify something. ठीक है, तो yeah. Not only might you be judged harshly for not really understanding Bigo, but you will also be struggling to judge when your algorithm is getting faster or slow. Yeah, that is true. If you are aware of these topics about the Bigo or the time complexity, you can judge or you can tell that yeah, this algorithm is much faster than this on theory. Okay? Or you can like optimize it based on if you are aware of how you can calculate the Bigo and how can you optimize them. Okay? So for the for loop, it is taking n as Bigo. Okay? And if you do not use if you do not use for, let's suppose if it is possible, then it will reduce the time complexity. So these are all the terminologies that you will be learning going forward. An analogy, imagine the following scenario: you got a file ticket on a hard drive. You needed to send it to your friend who live across the country. Okay, you needed to get the file to your friend as soon as possible. Okay, okay, let me do one thing more. Okay, what the heck? I just wanted to bookmark this also. Okay, I have bookmarked it. Okay. Imagine you are got a file on the hard drive and you need to send it to your friend, okay, across the country. So you have to send your friend a particular file across the country. You need to get the file to your friend as soon as possible, and you need it to transfer as fast as possible because it is something urgent. Okay, how should you send it? Most people first thought it would be email or FTP or some other mean of electrical transfer. Okay, that thought is reasonable, but only half correct. ठीक है. So you also have thought of using email, or you also might have also thought of sending it with the help of WhatsApp or other things. ठीक है. And if it's small file, you are certainly right. It might take 5 to 10 hours. Okay, to get to an airport, hop on a flight, and then deliver it to your friend. Okay, but what if file were really large? Is it possible it's fast to physically deliver it via the plane? ठीक है. Yes, actually it is. 1 terabyte of data. This is a huge file. If you wanted to send this file over email or in WhatsApp or in some other platform, you have to think it through. ठीक है. You can't really send this big of a file through these things. Let's see how they are stating that can be done. ठीक है. 1 terabyte file could take more than a day to transfer electronically. Okay, it would be much faster to just fly it across the country. Okay, that is true, because yeah, that is going to take much more time. Okay, if you are transferring this big of a file, okay, so it is better to just go by flight or some other mean of this resource to travel. Okay, if if your file is urgent here, you might just wanted to do that. Okay? Yeah, that is true. What if there was no flight and instead you have to drive across the country? Even then, for a really huge file, it would be faster to drive. Yeah, that is true. Time complexity. Okay? This is what the concept of asymptotic runtime and a big O of time mean. We could describe the data transfer algorithm runtime as electronic transport, big O of S, where S is the size of the file. This means that the time to travel the file increase linearly with the size of the file. Okay, that is true, because S is the size of the file. If the size is bigger, it is going to take much more time than initially it should have. Because yes, this is a bit of a simplification, but that's okay for these purposes. ठीक है. Airfoil transfer. Let's suppose if you are traveling through flight, ठीक है, तो it does not matter how big of a file it is. Okay? Even for the smaller files, it will going to take the same amount of time, because you have to travel that much distance. it does not care. Okay, so it is going to take the similar time, because that is why it is showing big O of 1, which is a constant time with respect to the size of file. As the size of the file increases, it would not take any longer to get the file to your friend. The time is constant. Yeah, that is true. No matter how big the constant is. Okay, so this is the time for the flight, and this is through via email or some other means of electrical transfer. How slow? So initially, as you can see, for smaller files till this point, it is taking less time, but exponentially it is keep increasing as the size of the file increases. It is going to take much more time than initially it should have. Okay, that is true. They These are many more runtime than this. Yeah, that also happens with other things also. Let's suppose initially uh, maybe n square or 2 to power n has taken different time. Maybe 2 to power n initially has taken less time than n square. Okay, let's suppose for 1, okay, the 1 ka square, this is taking, okay, this is still a little long, but yeah, you can think of any example. Okay, so initially it could have taken small time. uh, yeah, so it could have taken small time. Let's suppose if it is initially it is taking less time, but it could increase exponentially, and that might affect our algorithm. ठीक है, तो for the early startups we can think of something which is much faster initially, because we might not have to transfer that much amount of data. But going forward, when we have a much larger or more amount of data, we have to think through which algorithm we needed to implement, and what are the time complexity, and we needed to make those trade-offs. ठीक है? These are no find list of the possible through. Okay, I don't know what to make note of, because I don't know, so I come up with okay, anything that is new. You can also have multiple variable in your runtime. For example, the time to paint a friends, that w meter wide and h meter high could be described as big O of w or h. This is the time it is going to take if we are initially thinking that we are painting it one square at a time. Okay? So it is going to take w of h amount of time. Okay? If you are needed p layers, then you add up a layer also, then it is going to take a big O of whp. Okay? What is the difference between big O, big theta and big omega? Okay? If you are never covered big O in academic setting, you can probably skip this subsection. It might confuse you. Okay, so we have covered it, but if you also have not covered it, this thing, you can skip this thing. Okay? This FYI is mostly here to clear up ambiguity in wondering for people who has done big O before, so that they do not say. But I thought big O mean academically we use big O, big theta or big omega to describe runtime. Okay, that is true. That should be true, right? Because I also think it does the it does use to describe runtime. मतलब, big O in academy, big O describe an upper bound. Yeah, it is true. On the time and algorithm that print all the you could also think or say it as a worst time. Okay? At worst time, what is going to be the runtime? An algorithm that print all the value in an array. Just give me a minute. just making my coffee. Yeah, so where was I? In academy, they go describe an upper bound on the run on the time and algorithm. Okay, so we were saying here. An algorithm that prints all the value in the array could be described as big O of n, but it could also be described as big O of n square or n की power 3, big O of 2 की power n, or many other big O times. ठीक है, the algorithm is at least as fast as each of these. Therefore, there are upper bound on the runtime. This is similar to the less than equals to relationship. If Bob is X years old, I will assume no one live past 130. Then you could say X is less than 130. It would be also be correct to say that X is less than इतना. Okay. Okay. So it state this thing that let's suppose if we have to define a upper bound as lowest upper bound, ठीक है? if you get what I mean, you have to define a lowest upper bound. Let's suppose for an algorithm you can't perform some add to some extent. Let's suppose for this thing if we are defining an age, a person can't be past 130. ठीक है, तो we are saying initially that yeah, X whatever the value of Bob, whatever the age of Bob, ठीक है, तो it will never be going to go past 130. But we can also say it is not going to pass 1000, and we can also say it is not going to pass 1 lakh. ठीक है, तो it should be lesser than this. So that is also true, but we have to define something very less or the upper bound. ठीक है. This is not supposed. So we have to define the upper bound. Let's suppose this is the line there, and there was a X, and this is the threshold. But we can say this line can't cross this line, but we can also say it will not cross this line also, this point also, because this is the limit, but this can also be a limit if we are going in this direction. Okay, that is what it's trying to say. But we have to find a minimum point or the upper bound of this. Okay, so the upper bound of this, we have to find that point, and we call it big O. Okay, that is where this confusing statement, because it is stating less than or equals to. Okay. And then big O omega. In academy, omega is equivalent concept but to lower bound, printing the value in the in an array omega n as well as this. After all, you know it wouldn't be faster than those runtime. Okay, so this is something which is if you are thinking of this as a upper bound, you think this as a lower bound. Okay, so yeah, this you don't really need it to learn about this. You just need to aware about big O of big O. Okay, so that is the most important thing. Other than this, even if you don't understand big omega, you don't understand about big theta, that is still okay. But you definitely need to aware about what big O is. Okay? Let's read about big theta. In academy, theta means both O and omega. That is an algorithm. Okay, theta, and if it is both big O of n and omega of n, theta give a tight bound on the runtime. So this is something which is both. Okay, and that is how it is. I don't think so I need to explain anything, because it is as it state. It is just plain English. I think you guys will get this thing. Okay? Let's just move on. In the industry, people seems to have okay, we can do I don't, but we really don't have to. Okay, but let's just copy paste these things together because I don't have any other topic other than this that I think I should be. I also think I don't think that I should be covering this also, but we have to cover something, right? Well, you can ask ChatGPT for this. Okay. It is quite large. We might have to separate it like this, but this is we will cover into this much on okay. Describing the upper bound runtime algorithm, it would not grow faster than this because linear search is big over n because in worst case it has state of very if you are not aware, if you are not still understand one thing together, I just wanted to highlight it here. This is the worst time case scenario. This is the best time case scenario. Okay? And this is where you can say where best and average are same. Okay? If I try to search for the terminology, okay, which is best, comma, average, but worst case. Yeah, this is the best case scenario, omega. This is the worst case scenario, and this is the tight bound. Yeah, you could say it. You could say that omega is theta is something where the best case and the worst case is same. Okay. Let's suppose if you are trying to print an array. For you to print every element of array, you needed to perform big O of n or omega of n. Okay, it does not matter. Let's suppose if you are trying to search a particular thing in an array. Okay, you could get in a very in the first element. Then the time complexity at that particular time will be big O omega of n. Okay, but it could also be the case that you will find that element at the very last. For that time it will be big O of n. But let's suppose if you wanted to print something, then you needed to perform all of the operations and you have to go through with every element. At that time it does not matter the big O and big omega, they both are the same. Okay, so we can say it like this. I dot comma omega, yeah, big say also this thing here. So in this case, this thing happens. I will just adding this for the reference. Okay. In industry, people seems to have merged theta and big O together. Industry in industry, people seems to have industry meaning of big O is close to what academically mean by omega. Okay. Yeah, because we most of the time we just search for big O and we think of it as uh, big theta because we don't think of big omega because we what why does it even matters that even though for some cases we are getting it faster because most of the cases it might can take at worst time complexity but we have to think about that part. Okay? Industry meaning of big O is closer to yeah. In that it would be seems an incorrect to describe printing an array as this, and industry will be saying this is a big O of India. That is true. For this book, we will be using big O in the way that industry tend to use it by always trying to offer the tight description of the runtime. That is okay. That is understandable. Best case, worst case, unexpected case. ठीक है तो these are all the things. ठीक है we can actually describe our runtime for an algorithm in three different way. Okay, that is true. We already have a little bit of understanding what these things are. Okay. Just a minute. I'm just taking a small break. Yeah, okay. Let's look at this from the perspective of Quicksort. Okay, so if you are not aware of Quicksort, let me show you what Quicksort in DGC. We point a pivot, ठीक है yeah, so this is how we say it is what it is. We divide and conquer. Okay. Just a moment. I will be back. Yeah, okay, so where was I? Okay, the I was explaining quicksort again. Okay, so what we do in quicksort, we choose a pivot. Let's suppose we take it at random, that or you can pivot. You can think of as a pointer, or you are pointing to this point. Okay? You can choose it randomly. You can choose it like let's suppose for the very first or the very last. Okay? Totally depends on you. Okay? A good pivot can uh, reduce the recursion calls. ठीक है तो और then this is something that happens. ठीक है so it totally depends upon you if you wanted to choose a random pivot. Let's suppose if we are taking a 5 as our pivot, so in the left side of 5 we are taking elements lesser than 5. ठीक है तो we iterate from these things and we keep track of elements that are smaller than 5 and greater than 5, and then we divide them. Okay, so this is how we divide them: 1, 2, 4 and 3. These are all the things that are lesser than 5, and 6, 7, 8, 9 that are greater than 5. Okay, we then do this thing recursively, and then we choose a pivot, let's suppose in this case, which is 2, and then we keep iterating it in the other element, and then choose a particular element. Let's suppose for this case, like sorry then we like divide it, like 1 and 1 is lesser than 2, and then 3 and 4, then we choose pivot. There is nothing to divide, then this will be stop. Okay, this will stop, and then we do this thing okay, recursively, and yeah, that is how we divide, and then we merge them. Okay, so we uh, got our output, if you can see. Okay, pivot wise 1, 2, 3, 4, 5, 6, 7, 9, 10. ठीक है तो we have sorted the elements successfully. And this is how the quick sort works. ठीक है so yeah, let's just see if you want to visualize I think I have the visualizer. Is this the one? Okay, it is not. I think this. Okay, we have quicksort. Let's take an example of 8 bar and array. We don't need it. Okay. ठीक है तो let's suppose if we had this, ठीक है, which is unsorted, so what is going to happen? It is taking a pivot, then it is just like going through every element. This will go behind, and we go through every element. ठीक है, and then we do the partition. ठीक है, whichever is lesser than it, we just move it to the left side of this pivot. ठीक है, which we have initially taken. ठीक है, if you can see, I think this is also not clearly visualizing it. ठीक है, you will not be able to see what actually is happening over here. Do we have this? But that is how it happens. ठीक है, it is also not have visualized it correctly, but yeah, somewhat like this. ठीक है, I will be back in just a moment. ठीक है, till then if you wanted to read this, then you can read. best case scenario, we have already discussed about it here. If all the elements are equal, then the quicksort will on average just reveal. So this is nothing. This is you can think it as also omega. Okay, and this is big O. Okay, let's read about this. Usually through these wonderful and terrible situations wouldn't happen. Sure, sometimes the pivot will very low and very high, but it would not happen over and over. We can expect a runtime of itna. Okay, that is true. Okay. These are all the worst case scenario and the best case scenario, but normally it is like this. Okay. We rarely even discuss the best time complexity. That is also true. Okay. Yeah. We rarely discuss the best time complexity. Complexity because it's not very useful concept. After all, we could take essentially any algorithm. Okay, special case special case some input and then get the big O of one time in the best case. Okay, that is true because we can think in the best case scenario, we depending on the algorithm we can take the best case scenario for that particular output, and we can say that yeah, this algorithm is big O of one time complexity, but that is not true because at the worst time it is going to take much more time, and in the real life we can't decide, or we can't be have control over what could be the input, because in real time we can have any input because we have to think for the worst case scenario. That is true. That is true for many, possibly most algorithm, the worst and the expected case are the same. Okay, that is true. Sometimes they are different, though we need to describe both of the runtime. ठीक है. What is the relationship between the best, worst, and expected case with the big O, theta, and omega? Okay, so we will be learning about it. for candidate to model these concepts, probably because both has some concept of higher and lower and exactly right, but there is no particular relationship between the concept. Okay, what best and worst expected describe the big O time for the particular input and scenario. Big O or big omega or big theta describe the upper, lower, and tight bond for the runtime, and that is true. Okay. Yeah, so let's just go to the space complexity. Time is not only the thing that matters in algorithm. That is true. We also might have to think about the space. Uh, we also have to think about the space. Let's suppose even though if you wanted to store something, you needed to also be aware about what is the storage that we have available for us to store something. So let's suppose if we are having a storage of one room and we wanted to store something which is uh, a little broader in size, if we not perfectly arrange them in order, it might also not fit in. Okay, so that we have should be aware about it, because that is something which is about arrangement, but we should also be aware about how much space we have. Let's suppose if we have a space of one room and we are trying to fit in these things that should be storing in at least two rooms, so it will not be fitting. Definitely it is going to create problem, and that is also the case for the code. Okay? If we have requirements, if we have the requirements to have only 200, or they you have definitely seen in on the code forces. Okay? Or maybe in lead code also. Okay? So let's suppose if I try to open any one problem. Okay? Let's suppose I try to open this problem. Okay? Okay, where was the problem? Let us open from here. Yeah. Okay, I think it only have a time complexity constraint. Okay, but uh, if I go over here and go to any problem, okay, let's suppose which was a basic problem. Why can't I find again? Let's say if we have, okay, this is the problem. Okay. So in here, down in here, you can see the memory limit is this. So you should not be storing which will exceed this space. So you should be aware of these things also, so that like you can also store within the storage. And you need to think of creating smaller element for storing something. Let's suppose there was some space constraints where you can't store something. Okay, so at that time what you need, how you can like perform, you can take time, but you can't store something. So at that time you have to think about it. Okay. Okay. is not only, yeah, that is true. We might also have to care about the amount of memory or the space and requirement by an algorithm, and that is true. Okay? Space complexity is the parallel concept to the time complexity. Okay, if we needed to create an array of size n, this will create big O of n space. So that is true. If we are uh, creating another array which is other than the given array, okay, so we are covering big O of n space. Okay, these are all the additional space. And let's suppose if we are creating an array, so it will be taking omega of n square. Okay, so if the two dimension array is both of n into n dimension, okay, so that then it is going to take big O of n square. But let's say if it is n into m, so it will be big O of n into m. But yeah, that is what true. Okay, and stack space in recursion call to, for example, code like this would take big O of n time and big O of n space. Okay, this is definitely taking big O of n because it is iterating through n recursively. Okay, so you will not be seeing a for loop, then you are thinking, okay, so this is not using a for loop, so it might not be big O of n, but it is because we are using this thing recursively and it is goes on n times. Okay, so till it becomes 0, only then it is going to return 0. Okay, let's suppose if we have taken 2 initially, so it will return 2 plus sum of 2 minus 1, which is be 1. So then it will then like goes again, then it will be 2 plus 1 plus sum of n minus 1 minus 1, which will be 0. Then it is going to return 0. So it will be 2 plus 1 plus 0, which will be equivalent to 3. Okay, so there, so this sum of 0 to 3, or the so that sum of n natural number, it will be what, 3. Okay, for this case, okay, where we have to get sum of first two n natural number, so it will be what, it will be 3. Okay? So it is taking n time. Okay, and to store the data, it is storing it over here, if you can see, if you understand what I mean, because it is creating every time a new variable, so it is creating another variable. So for that it is storing it over there. So each call add a level to the stack. Okay, this is true because let's suppose if we are taking example of sum of 4, then it is taking 4, then adding with sum of 3, then which will be what will be doing, it is taking 3 and summing it with sum of 2, taking 2, summing it with sum of 1, taking 1, then summing it with the 1. So these are all this we needed to store. Okay, and then we are also iterating it to the n value. So that is why it is having the time complexity of big O of n and also the space complexity of big O of n. Okay, so that is true. However, just because you have a n call, that total does not mean it is big O of n space. Okay, so that is true because even though you are calling it for the n time, it does not mean, because if you are not storing it. Okay, let's suppose if you have created initially a one variable which is sum, and then you have added it over it recursively or anything as such. Okay, so in this case it is a for loop, so it is going to take big O of one time. Okay, so it is not taking for the space time complexity, so for the space complexity it is going to take it is going to take big O of 1. Okay, so even we can shorten the time complexity also if you are aware about the sum of n natural number, which is n into n minus 1 by 2. I think that is sum n into n plus 1 by 2. I was thinking about it. So that this is how it get done, it gets done. Okay? There is also a rough big of and call to prime sum. However, those call do not exist simultaneously on the call or stack, so you only need big of one time. So that is true. Okay? If you have understand how we can decrease the space complexity by just creating one variable and adding into that particular variable, yeah, this is how we can do it rather than just creating the variable that is very unnecessary. Okay. Okay. It is very possible for big of n code to run faster than big of 1. Just a moment. Okay. So where was I? Okay. It is very possible for big of n code to run faster than big of 1 code, big of n code to run faster big of 1 code for specific input. Yeah, that is true. Okay, so it could be the case. Let's for big O of n code to run faster than big O of 1. One of their example was we have initially seen how if we have to send a file, let's suppose if it is a very less size, okay? Let's suppose the value of n is lesser than 1, so it will take less time than big O of 1, okay? So big O of 1 is, you can think of it as a constant time, okay? So let's suppose initially we have discussed about it, okay? So let's suppose if you want to send a file to your friend, okay? So let's suppose if it is a smaller file, you can send it via email, maybe with the help of WhatsApp, okay? So it depends on the size of that thing. It will take less time. Let's suppose if it is a 1 terabyte of space, it will take so much amount of time that it is better if you go with the flight, okay? So the flight time is constant time, and the time to send it via any social media or any other platform or any electronic device, it will be a variable time, okay? So that is an example where big O of n can outsmart big O of 1. It depends on the specific input, or there can be a various other example also, okay? Big O just describe the rate increase, okay? For this reason we drop the constant in runtime, okay? An algorithm that might be described, okay? So when we initially think of this, okay, 2n, we think of 2n as same as big O of n, okay? In big O we drop this constant, okay, because it is almost equal, okay? Because we are dealing with a very big data, and at that time these smaller things does not even count, okay? So if the value of let's suppose if the value of it is this, so it does not matter because it almost take the similar amount of time, okay? So yeah, that is true. Even for the addition, let's suppose if we have taken an example where we are having this, and if we add 2 with it, okay, so it will take almost the similar time, because this is a very big time, okay, or very big variable, okay? Many person resist doing this. They will see code that has 2 for loop and continue this big O of 2n. They think they are being more precise. They are not, okay? That is true, because even though if you have 2 different loop in a statement, okay, so it is going to take the time complexity is big O of n, not big O of 2n, okay? Consider the below a code, okay? This is the code, this thing, and I think this thing will going to run at the same amount of time, I think so. Which one is faster? The first one does one loop, and the other one does 2 for loop, but then the first solution has two line of code per for the loop rather than one. If you are going to continue the number of instruction, then you have to go to the assembly level and take into the account of multiple requirement more instruction than the addition. How compiler would optimize something, and all the because these are all the things that you should not be aware about, because you have to deep dive into. If you go deep dive into these things, you will be going to get more and more confused. So yeah, that is why I will just skip this thing. This would be a horrendous complicated. Okay, so don't even start doing it going down. Yeah, that is true. That is what I also told you. Okay? But Bigo always allow us to express how the runtime scales, and we just needed to accept it. Does not mean that big O of n is always better than big O of n square. And that is true, because yeah, I have already have given the example of, if you wanted to send a file, there could be a best case scenario for there could be an algorithm where the type of input that we are giving is more suitable for big O of n algorithm, and it is not suitable for where we big O of n square. Or it could be a vice versa, where it could be a best algorithm for big O of n square algorithm and not the best algorithm for big O of n algorithm. So it will take less time for this thing and greater time for this thing. So it totally depends on the input here. But we think of the worst case scenario. Drop the non-dominated terms. Okay, so this is something. Yeah, let's suppose if we are multiplying this again, let's suppose this into this is going to create something which is very big. So even though if we add it with this thing, it will almost be equal. Okay, it will almost be equal. So that is why we decrease the non-dominating terms. So let's suppose for n square, the degree, we take the highest degree. You could also think of it like this. Okay, we take the highest degree. Okay, that is what we do with this. We already said that we drop the constant. Therefore, big O of n square plus n square will be this. Yeah, that is true. If we do not care about the later n square term, why would we care about n? We don't. You should drop the non-dominating term. Together, this will become this, and this will become this, and this will become what? This. Okay? So that is true. We might still have a sum in runtime. For example, expressing big O of b square plus a can't be reduced without some special knowledge of a and b. Okay, so we needed to be aware of which is having a higher degree, okay? Which is having a worst big O. Okay? You can think of this at like this, and we keep that term and we erase the other term if both of the terms are equal. Let's suppose if we are comparing n with the m, that is not comparable. I will say keep both of the terms. But if you are comparing n plus n, you can remove one of the terms and you can keep big O of it. Okay? The following graph is so this is how you can see in a longer run, which is going to exponentially increase the value of y, or the time complexity. Initially, there might be the case. Let's suppose for the x square, initially you can see over here it is taking less time than the linear wala part. Okay? But going forward, it might exceed. Okay, might exceed the worst time complexity for big O of n when compare it with the big O of x square. Okay? And that is true. You have to think of it as that is. And yeah, as you can see, big O of x square is much worse than that is true, but it not nearly as bad as big O of 2 to the power itna. there are a lot of runtime worse than this. You can uh, do one thing. You can take okay, we can do this thing also, right? I think we have covered most of the things. So we okay. I don't think we should be making any other notes than this. One thing we can do, where was we? Okay. We were over here. I was going to search. We can take the nodes from here in an increasing order. I think this looks good. Or maybe this is better. I think this is in increasing order. Big of 1 is the smallest, then big of log n, then big of n, big of n log n, big of n log k, big of n square, big of n cube, big of 2 to the power n, and the worst of them all, which is big of n factorial. Okay? So this is something you can take note of. I will also be doing the same. Alright. Okay. I don't think so. There is another other better picture than that. Yeah. Okay. So as you can see, we have video multi-part algorithm, add versus multiply. Okay. I think in addition we are taking and for multiplication getting log n. You will understand here what I am trying to say. Suppose you have an algorithm that has 2 steps. When you multiply the runtime, when do you add them? Okay? So this is something you should be aware of. When you are trying to multiply, let's suppose this is the case, this is the best case. Okay? So even though there are 2 for loop, why are you adding them up? Okay? Why are you not multiplying them? So this is something that you should be aware of. Okay? This is also, they have also given us the example. Let's suppose we have 2 for like this and 2 for like this, why in which we are adding, in which we are multiplying. Let's suppose we are sequentially having the for loop. Okay? So then we will be adding, and we have a nested for loop for loop inside a for loop, so we will be multiplying. That is the difference between them. And then there was one more thing which we will be understanding, that is about why we are taking n for the for loop, and when we are going to take log n for the for loop. Okay, so we will be studying about that also. In the example on the right, we do big chunks of each. Okay, so this is something you can think, or you can remember it as it is. Okay, in other word, if your algorithm is in the form of do this, then when you are all done, do that. Okay, so yeah, you can think of it this terminology also, but I will not suggest you to think it like this. But you can think of it is like this: the sequential wala part, all the things that are is in sequential, it is going to add up, and all the things that are is in nested, it means one inside another, you are going to multiply for them. amortized time. ठीक है, even I don't know what this thing is. Amortized. What is this thing? What is the meaning of this thing? Gradually write off the initial cost or over a time. Okay. Amortized time. ArrayList, I think this is something which is inside Java, right? If I remember correctly. And this is inside Java. There is nothing like this in C++. Yeah, but let's move on. An array or a dynamic resizing array allow you to have the benefit of an array while offering the flexibility in size. You would not run out of space in the array list since its capability will grow as you insert elements. Yeah, that is true. If you are not aware about this concept here, I think this is similar to the vector in CPP. I will be giving the example of C++ because I am learning C++ right now, even though I know about how does it work in Java, but I am focusing on C++ still. Alright. So this is the benefit of you learning about something. ठीक है, तो if I am aware about that concept, तो I will definitely be able to search it over the internet. ठीक है, तो if you are not aware about these things, तो you will not be able to search it over the internet. ठीक है, तो this is what it is going to do. Let's suppose if you are having an array, you could say it as it is. ठीक है, तो then what happens? Let's suppose it is of fixed size. ठीक है, तो initially it is of this thing. And then you are going to add a particular thing over here. So then what is going to happen? Now the array is fully filled, right? Then what is going to happen? It is going to create a new array which is of increase one size. Okay? And this thing happens with I think more than this. I think they have not explained it in the right way also. Because it take, let's suppose for the initially 16 bytes of space, then as the things code fills up, it converted into 32 automatically and make a copy of it. These thing happens at a very low level, but you can think I don't find any reference here regarding the dynamic memory location. Let's try. Okay, we are not getting what we wanted to search. I think it is inside also. Finding a suitable resource to describe what I'm trying to say. It is something like this. Let's suppose if we have this thing, okay? If we have this thing, what it is going to do, let's suppose if we are trying to insert something, okay? And then it is going to create it in a different address, okay? And then it is going to increase the size of it, okay? So let's suppose initially its size was 5, it can store 5 elements, so it is going to increase it double, okay? It is going to double it, okay? So if it is 5, then it is going to be 10, okay? And that is how it happens, and that is also the reason why we do the pointer वाला part. ठीक है, I'm not getting exactly the resource. It's pointers in free code. Okay. Okay. I'm not finding. Why can't I find it? So this is also a good article. We can read this or to understand the program memory. Okay. We will be reading this. We will be reading this. Where, wait, can I? Okay, just give me a minute. Okay, I will try to store it in at this time. And this also I will try to store it in at this time. We will be reading it because I think this is something which we should be reading, but not now because I don't want to be hopping around different resources. But it is a good resource. I will. But I'm not getting what I wanted. I don't know why. Okay. We can also explore some of the resources that are provided over here because I really find these things very useful. C++, let's see. C++. Didn't I search for C++? Why is it giving me? Okay, we can bookmark this also. We will think about it later, that which to choose. But yeah. You can read some of the articles from here also. We will see, but yeah, this is something that, let's suppose if we have filled your initial array, okay, and then it will going to double its size, okay? Only then it is going to double its size. Let's suppose if it has a size of 5, then you have taken all the size that you have initially defined, then it is all then only then it is going to increase its size, okay? I think, what was the name of this that thing? I literally forgot about the name. What was it? You will not be seeing anything on the screen as of now because I'm trying to search for something specific. And it is in the history, so I don't want to share it over internet. Where was it? I literally have searched it a few days back, right? Then why don't I get it? Where was it? It was literally a few day back, right? Okay, this is the another. Okay, we get what we want. Okay, I was trying to search for this thing. Then we were able to see what is happening. Suppose if we are compiling something, we are able to see the location of the memory. I will be doing one thing. I will bookmark this website so that like I don't forget. This is a I don't want to save it in any folder, but let's say if I really wanted to just bookmark. I'm still not able to understand this website fully, but yeah, this is a good website if you wanted to see how everything is locating or how everything is working behind the scene in the GCC compiler. Okay, so this is a very good website that I found while exploring. But yeah, let's not divert from our topic that we already have. But yeah, an array list or a dynamic resizing array allow you to have the benefit of an array while offering flexibility in size. You would not run out of the array list since it capacity will grow as you insert the element. Yeah, that is true. An array list is implemented with an array. Okay, when the array hit the capacity, the array list class will create a new array with a double capacity. Yeah, that is true. That is what I'm trying to show it to you, but I directly don't find the reference for this. Okay, so if I really find the reference for it in the future, I will be sharing it. Okay, and copy all the element over the new array. So that is true, and that is also the reason why we create pointers and why we needed pointers, because every time we have to create a new array, we have to reallocate it at a different memory address, and the previous memory address get wasted. Okay, so that is true. And how do you describe the runtime of the insertion? This is tricky question. The array could be full. If the array contain an element, then the insert a new element with the big O of n time. You will have to create a new array of size 2n. Okay, that is true. And copy the n element over. This insertion will be big O of n time. So yeah, that is true. Let's suppose if the array is already full, okay, let's suppose if we have an array and it is already full and we wanted to additionally add some new element which is also an element, okay. Sorry, we wanted to add a new element, okay. So it is going to, how much time it is going to take? What do you think? Okay, so let's suppose if you wanted to insert it at the behind, for now it might take a less time, but uh, if you wanted to insert it in between, you have to iterate it till there. ठीक है, तो you have to think of it as big O of n time. ठीक है, तो you for insertion, ठीक है, you will have to create a new array. ठीक है, तो for that you have to create a new array at a different memory location and then copy the previous an element over there and then insert the new element. So that is how it happens. ठीक है, however we also know that this does not happen often. So yeah, this is does not happen. This is the trade-off. This is where the trade-off comes in, that either you wanted to have a fixed number of size, or you wanted to have a size that you don't know that you might can exceed that size, and you wanted to have it a dynamic wala part that you don't know how much size you wanted to take, and you wanted to save as much size you want. So at that time you take the concept of pointer and you save it in different location, and just the tail of that data will pointing to that pointer. ठीक है, sorry, the tail of that thing is pointing to the address of the next array or next data that is stored. ठीक है, and yeah, that is how it happens. The array could be full. Okay, however, we also know that this does not happen very often. The vast majority of time insertion will be big O of n time. Okay, that is true. We needed a concept that take both into accounts. Okay, this is what compute system does. Okay, so this statement is something. Let's suppose initially for you to push an element, okay, into an array from behind, it will take one big O of one time. But let's suppose if the array is full, it has to double itself, so it required big O of n time. Okay, so yeah, that is what we're trying to say, to create a new element, so to create a new array which is double its size. Okay, we needed a concept that take both in account. This is what ambiguous time comes in. Okay, so it allows us to describe that yes, this worst case happens every once in a while, but once it happens, it would not happen again for sure, for so long that the time is ambiguous. Okay. in this case, what is the ambiguous time? Okay, so let's suppose if you have created the double of the initial thing, so it will take some time to fill the newly created array. ठीक है, तो yeah, that is what they are trying to say. As we insert the element, we double this capacity when the size of the array is 2. ठीक है, power of 2, sorry. So we after x element, we double the capacity of the array. Okay, so this is how we are doubling it. ठीक है, तो for 1, then we create an array of 2, then we create the array of 4, then we create the array of 8, and this is how it goes on. The power, it goes on the power of 2. Okay, so what is the sum of these things? If you know about GP, you can definitely find out what is the sum of this thing. Okay, it is nothing. It is just the sum of the GP, because we are just doubling it. Okay, so this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power this and so on. Okay, if you read this sum left to right, start with 1 and double it until it get x. Okay, so what then? If you read it right to left, it start with x and half until it's 1. Okay, that is true. What then is the sum of x plus x by 2, x by 4, x by 4 plus till 1? This is roughly 2x. Okay, therefore x insertion take 2x time. Okay, this is how they are calculating. Okay, they are calculating in this way for x element. It is taking this that much of time. Okay, the ambiguous time for each iteration is this. Okay, we have a lot of things to cover, but I think this is where today's stream will be at. Okay, we have covered a few of things, but yeah, we will be covering it on tomorrow's stream. Okay, but yeah, that is all for today. Hope you like this stream. If you like this stream, make sure you like the video. Okay, and if you love watching content around DSA, interview preparation, or maybe C++ or Python, or creating something or building something, you can subscribe to my YouTube channel. I will be making content around these. Good night.